Hello, I'm going to walk through doing a simple Lazarus application. Scenario: EG4 makes an inverter and solar charger meant to be put in small to moderate sized houses, giving up to 3,000 watts of alternating current and handling as much as 5,000 watts of solar panels. The inverter solar charger is reasonably priced. The accumulated voltage of the panels can be in the range of 120 to 500 volts. It would be useful to know how many panels of specific wattage it can handle, the approximate cost, and the minimum and maximum VOC, which is the voltage, of the panels which are going to be used. I am assuming the panels will be wired in series, which is the easiest way to wire it. In that case, the voltage of the panels can just be summed. The first step is to start Lazarus. Lazarus has its own editor built in, and it actually has a look and feel of the old Turbo Pascal, except a graphical format. Now, Lazarus is all form-based. You attach the source code to the form in the form of objects. For this example, I'm going to need a larger form. And the first step is probably to name the form. And we go down to the object inspector and we look for the field name, and we're going to call it EG4 form. And then we're going to want to save everything so that the project is at least written to disk somewhere. And I will have to create a folder for it to exist in. I keep all my Lazarus projects in separate folders. We probably should give the project a name. Click Save. It's going to want us to save the Pascal unit, and I'm going to just call it main. All right, it is saved a blank form with no source code added as of yet. The first thing we're going to need is what is called a string grid, and it's under Additional on the tabs here. And it's the one with the ABC below it. We just click on that and then click on the form, and we've got one in here. I'm going to enlarge it because it's going to hold a lot of information. And this form is going to need to be a little wider. Now, we're going to want to name the string grid. You can leave it without changing the name, and it would just be string grid 1, 2, 3, or however many grids you happen to have. I am going to name it Solar Panel SG. The SG stands for Solar Grid, or String Grid. And then we're going to want a button, and that's under Standard. And it's this with the OK on it. We'll just click it again and then click down on the form, and we can drag it around to wherever we want it. And I like things to line up. It usually gives you little lines to indicate that it's lined up. And I'm not finding the lines. I need to name this. We're going to call it the Calc button. I name all my buttons ending with BUT. And then there's a field in here called Caption, which is the displayed name. And I'm going to change that to just Calc. Now, if we double click on this button, it will give us a procedure in which to add some code, some actions to happen when we click on the Calc button. The first thing we want to do is set how many rows and columns we have in our string grid. And I want to set it to 5 for each. I put spaces around the assignment characters to make it easier to read. As an author I have read has stated, you read it many more times than you write it. So make it as readable as possible. Now you can declare variables and constants within the procedure that are just local to the procedure. We will go, when we talk more about procedures, I will further explain this. But I'm going to declare some constants. In the constant section, we just use an equal sign to assign a value. Everywhere else, it is a colon equals. I know we're going to need at least an I for an integer in the for loop. And we're going to need some doubles like watts and such. Now we're going to go down and do a for loop. Now, if we try to write beyond the number of rows that we created in our string grid, our program will crash. So the first thing we should really think about doing is increasing the row count every time we loop. And we can do that by just saying solar panel just as we just set it to, we just increment the row count in solar panel string grid each time we loop. And that's going to be the last thing we do within the for loop each time. Now we want to define watts. And we're going to start it out at 200. Plus I times 5. That should increment it by 5 watts each time. All the solar panels I have seen have been multiples of 5. And to put a value in our grid, it's assigned using XY coordinates, just like back in school when you graphed a formula on the XY coordinate system. So it's just going to be our grid the field within that, or the function, is cells, and it's going to have two variables, the x coordinate and the y coordinate, just in that order. And the x coordinate, everything starts at 0 within string grids. And we're going to say I plus 1. I being the variable in the for loop that we're looping through. And then we're going to send a string to it. Now in Turbo Pascal and Free Pascal, there is a function called format float. And the first part is how we formatted it as. If you put a pound, that will allow it to the numbers to shift to the left. If you put a 0, it's going to be fixed. And we're going to put a 0, comma, 0, 0, 0, single quote, comma, watts. And then a right paren. Now we're going to test this and see if it worked. See if we actually got data out there. We do that by just pushing the green arrow here. It's going to compile. It only takes a few seconds to compile something this small. We'll click on the Calc button, and there they are. Next, we would like to know how many panels we're going to be needing to maximize the wattage coming in. We can't go over 5,000 watts. So it's going to be 5,000 divided by the watts. Now, we don't want fractional amounts. We want it to be at the bottom for that value. So Pascal has a floor function. It's been around since Turbo Pascal, and it rounds down. In fact, C has something very similar to the floor function. Now, instead of 0 I plus 1, we're going to have it at 1. We want it in the second column. And this is going to be panels. We're also going to want to know what the actual wattage is going to turn out to be, the maximum wattage. So we're going to take watts times panels. And then we're going to want to know what the minimum and maximum VOC is going to be. We know it has to be at least 120 volts. So we're going to take 120 divide that by panels. And the max is going to be 500. This is going to be in the third and fourth column. Actually fourth and fifth, but now let's test it and see what it looks like. And the floor is in the math unit. It got moved to the math unit somewhere around Turbo Pascal 5.0. It used to just be part of the standard library. If we go and look at 412, which I have looked the numbers up before, or 415, yes, it requires 12 panels. It's going to reach up to 4,980 watts. It's going to require a minimum of 10 amps, or I'm sorry, a VOC of 10, and a max of 42. It has to fall within that range. It might be nice to put some headings in here. We could put the heading information here. We can just grab those. We won't have format floats here. We'll just put a string. And instead of I+1, we will have these all at 0. Because that would be the heading line. And let's look what it looks like. We probably should be sending this down one more line. There, that looks pretty good. Now we really need to approximate what the cost is going to be. And we can put in what they call some edit fields. They're T-edits. We can put them over here. The first one would probably be something like unit cost, and I will name it unit cost edit, because this is a T-edit field. And we don't want those alphanumeric characters in there, so we're going to go to text, which is where that is, and just delete it. And this one we're going to want to be estimated cost edit. And again, we do not want the alphanumeric data in there. We can also put some heading lines up here. That is standard and the ABC here. And we just change the caption to what we want it to be. There can be spaces in here. And we do it again for the next one. Now on the string grid, we have an event on click. If we double click inside the field, it will create a procedure for us. And we can create some variables for the local here. We want one for unit cost, and we want it to be a double. and we want to convert the TEdit value to a double. So it's just going to be string to float, which is a standard Pascal function. It wants a string value, and we're going to put the TEdit in there. The text part of the TEdit. Now we want to grab the number of panels out of this string grid for whatever we're interested in. And it's going to be a string value. I'm going to just call it panel string. We're going to say the string grid, but if we have clicked on the string grid, it's going to have us on a specific row. So we can say solar panel SG dot cells. The panels are in column 1. And the row will be dot row, which is a variable in the string grid. Now, unfortunately, that is going to have some commas and possibly spaces in there, and we want to get rid of them. And we're going to need an integer. We're going to have to step through the string and remove all the commas and spaces. So we're going to create a long int. Now I'm going to step through it backwards because if we delete a character, it's going to change the length. We don't want to change the length at the beginning. We want to change the length at the end. So we're going to do a for. Length is a part of the string library that came originally from Turbo Pascal all those years ago. And it's going to be panel string. And instead of 2, we're going to say down 2, so it goes backwards. And I think we're only going to have one statement in there. Copy is also a part of the string library. And delete is a part of the string library. It will delete a number of characters from within a string. Now, after that is done, we can convert the string to a float. And finally, we're going to put the estimated, let's see, we've got number of panels, a number of, and cost. And the name of that string, estimated cost edit. Now we can put a floating $sign inside our string. And I think this will work. We need to put the cost in the field ourselves. And if we come and click on the row, it should grab that value. And it did. And if we take $184 by times 12, it should be approximately that number. If I do this correctly. 2208. So basically we have a working app here. Now, if we go out someplace and I have seen these on Facebook, and let's say click on these 550 waters. In here they should publish the VOC and they say 49.6. So if we go back to our and find 550 watts, we have to keep it between 13 and 56. And I probably should have put those with .00s because there will be fractional values. And we can change that real quick. Go back here. There is something I forgot to do. We can resize the cells to make them appropriate for the amount of information in them with just a solar. There is a function in here, auto size columns, and that should do it. I don't seem to be able to get rid of that right now. Go back to 550. And we have to keep it between 13.33 and 55.56. And as we looked, it was 49.6, which is acceptable. If you have any questions, you can write to me at this address.